Welcome back to physics. We are in module 6. We're working with Newton's third law. Let's go ahead and address a misconception that comes about with this, or that this law can help clarify. We'll jump over here to the main screen. Okay, so to begin, because Newton's third law says that when two objects push apart, or when they combine or collide, the force is equal between those two. That means that the accelerations have to be different. Think about this. Well, let me tell you a story. Last summer, went for a motorcycle ride up over Monte Cristo. There we go. I was going up to Bear Lake, and as I was going up over the mountain pass, we encountered a bunch of monarch butterflies. They were, I think they were like flying one way or the other, and there were hundreds of them, thousands of them. And when I ride the motorcycle, I ride with my face shield up because I like the air blowing in my helmet. I don't like having the face shield closed. And one of those monarch butterflies happened to fly in and hit me on the cheek. It hurt pretty bad. And the monarch butterfly, I have to tell you, didn't make it. But I did, right? Why was I able to make it through it and the butterfly not? Because if the force is the same, well, it doesn't seem like the force is the same because the butterfly was obliterated all over my face. But I mean, you know, I still have most of my face there. So, and it's because the force was equal, but the acceleration was different. Let's talk about this. So, force is equal to mass times acceleration, right? Remember that the units for mass is kilograms. The units for acceleration is meters per second squared, right? And the second, not 2 squared, let's do second there, okay? And the units for force is actually these multiplied. So this is, by definition, newtons. That is newtons, okay? All right, so let's take the mass, my mass, and the mass of the butterfly. My mass is about 99 kilograms. The mass of the butterfly is about 0.5 grams. I mean, I didn't measure that one, but on average, monarch butterflies are about half a gram. First thing I need to do is, in order for me to compare these, I have to get common units here, okay? So I got to convert half a gram to kilograms. That means I got to move my decimal place 3 to the left, which would be 0.1235 kilograms. Those two are equivalent to each other, okay? Now let's go ahead, and since the force is equal, okay, and let's just say that force was 50 kilograms, or not kilograms, 50 newtons. Okay, let's say that the butterfly and I collided with a force of 50 newtons. Cool. Okay, so I don't know, I know the mass, I know newtons, I know the force. The thing I don't know is the acceleration. So I need to get the acceleration by itself, so I'm going to divide both sides by mass. And I end up with acceleration is equal to force divided by mass, okay? So let's go ahead and let's calculate my acceleration. And remember, because these two things are colliding, my acceleration would be in the opposite direction of my travel, and because I'm larger, the butterfly's acceleration would be in the direction of my travel, okay? The butterfly would slow me down a little bit, and I would speed the butterfly up a lot, okay? So we got 99 kilograms times meters per second squared, because that's newtons, that's my force. Okay. And, no, I messed that up. Sorry, I messed that up. Let's do this again. Let's get a little bit more room here. So, it was the force, which was 50 newtons. 50 newtons divided by 99 kilograms. That's better. Okay. Remember, newtons is kilograms divided times meters per second squared. Okay. So the kilograms cancel. And that is equal to, let's get a calculator. And so 50 divided by 99 is equal to 0.51. So 0.51 meters per second squared, and that was my acceleration in the backwards direction. It was pushing me, my face back when we collided, okay? So now let's go ahead. 50 newtons remains the same, so that was the acceleration of me. What was the acceleration of the butterfly? Okay, 50 newtons, which is, we know, is kilograms times meters per second squared. Okay, and the mass of the butterfly in kilograms was 0.0005 kilograms. The kilograms cancel, and I just get meters per second, which is good because that's what I wanted, meters per second squared. Okay, let's grab our calculator here. Oh, it disappeared on me. All right, so 50 divided by 0.1235, that's 100,000 meters per second. So the butterfly had a acceleration of 100,000 meters per second, and in what direction? Well, it would have had the direction that my direction, right? Because its acceleration was so much greater, it was being drug along with me, so that was in my forward direction. Okay? Hope this makes sense. We'll play with one more here in a little bit. Have a great one, and I'll see you in the next video.